Remember, you have this many more to do, and it's hopefully it's highlighted. I've been watching those numbers, and some folks are right about at half right now. Which, if you think about it, we're roughly halfway through the term. That's right where you should be. But even if you're not, even if you needed all 10 right now, you could get them all between now and the end of the term.
Yeah.
So I've got an in-class one. We won't get to it today. We'll get to it on Tuesday. That counts against the 10. So we got you guys taken care of.
And the one on Tuesday counted against
Yes, the one on Tuesday counted against that 10 as well. Hopefully you noticed that as it went through. Yes, all the in-class ones count against them. I won't offer, unfortunately, 10 in-class ones just because I don't think I have 10 yet. I'm getting there. But you'll have like 5 or 6, I'm guessing, by the end of the term.
Okay. So if we attend class, well...
I think I can count at least 5 from memory. My memory's pretty bad. There might even be a 6 or 7 in there.
Okay.
So yeah. Like I said, I try to give you guys more. Choose your own adventure. Choose your own adventure. Please, Tom.
We were not in class. Do the in-class want to bring it?
Bring it on Tuesday. Yeah, I gave you the link. Just print it off because it was a hand-in. There's no Blackboard link for it.
And that'll count.
Say again.
That'll count.
That'll count. Totally. And you don't have. I had everybody working with. Well, not everybody, but I had some folks working in pairs. You don't have to do that if you don't want to. You can totally work independently. All the data's right there on the paper, so you're golden. So here's where we were. If you distill it all down. Actually, kind of, there's where we were. Oh, you can probably see it on the back of my head, can't you? Yeah. Here is where we were. This is where we spent a lot of time dealing with this.
Right.
And now I wanted to compare and contrast the sample versus the population. You want to know these. You want to know what your population average is. It's called mu in the world. When you see a mu in statistics, it means the average of your population, whatever that is. It might be the average weight of a 5-year-old. It might be the average range of motion of a 35-year or a 41-year-old recovering from rotator cuff injury. Maybe. It could be anything, honestly. And that average has a plus or minus around it. But you never know those things because it's in your population. So what you are forced to do is to draw these from a sample. So remind me what an average is. When I say the word average, and I don't mean median or mode, I mean the mean, the average. What comes to mind, friends? The word average. Please, Jay, what comes to your mind?
Center of data.
Good! The center of data. Very good word. We actually call that whole thing measures of center, right?
Yeah.
We loop the median and mode in there too. I love center. Center. Good. What else comes to mind? What else comes to mind when you think of the average? I mean, the formula is adding up and divide by how many you got. But Kevin, go ahead.
Yeah, the whole thing about spreading out.
Right. Yes. So if the average income, I'm making this number up right now. If the average income in a certain town is $50,000 a year, that means if you took all the salaries of everybody in that town and threw it all into a pot and then divided it up into the number of piles of people that are in that town, they'd all get 50,000 bucks. It might be that nobody in that town actually earns 50,000 bucks. But the average is 50,000 once you spread it out evenly across the board. Fair enough? And that's what the formula is doing, sum up and divide by. That's what it's doing. It's equalizing. It's making the variability shrink to 0 because everybody gets the exact same thing. Good, very good. How about the standard deviation? Put that in your own words. What does that mean? And just so you know, this is part of your exam, is writing out what a standard deviation of the chicken egg production is. So, what is standard deviation? You see this number S. Let's say it's 5. I don't know, make a number up. It's 5. Huh? What does that mean? 5 what? What do you think? 5 what? And you know, it doesn't have to be 5, anything. What is the standard deviation of a set of numbers? Sandra?
The plus or minus from the mean.
So you got the average, you got plus or minus the mean. Do we know something about how much data is in between that plus or minus? So suppose the mean is, I don't know, 10, and the plus or minus is 2. Do we know what percentage of data is down 2 and up 2, so 8 to 12? Linda?
The first standard deviation would be 68%.
I'm going to put one 2-letter word in here, and you're going to finish it. If! There we go, beautiful. If the data is bell-curved, we're going to get about 2/3, 68% of the data within one standard. How about 2 standard deviations if it's bell-shaped? Good. I got a whole quiz for this for you guys for next week to analyze this. How about 3 standard deviations?
99.7.
Ooh! Oh, bam! Good. Good. Very good, very good. So, excellent. If the data is bell-shaped. What if it's not bell-shaped? Does it tell us anything? Does the standard deviation tell us anything if it's not bell-shaped?
Well, it gives us the measure.
What good? The measure of what? What is that little S value actually measuring?
How far something is from,
Say that again, Anna.
how far something is from the average.
On,
Middle.
say where you've already said, on average. Macy, go ahead, finish it off.
The distance from the mean.
Good. On average, it's how far the data points are from the mean or from the average. Good. You kind of have to use the word average twice. You have to use, here, I'll back up one slide. I think it's on this, it's right, yeah, it's right here. It's the average distance between the average and the sample data. You have to use the word average in there twice because it's being calculated as a distance from average. It is being calculated as a distance, don't worry about this. We bypassed that on, I'll come back to it in a second. It's calculated as a distance from average, but then all those distances are averaged together to get that measure. Now this might look horrendously awful, but if you psychoanalyze this, or meta-analyze, or mathematically analyze, the average sum x f divided by n is right in there. The average is actually in. You look nervous. Get away from it. Sorry, don't even look at that again. I'll erase the video later, so like it never existed. So basically, remember we did the Portland Marathon data in class? That was what you were bypassing, was that formula. It's a beautiful formula. It's one of my favorites in statistics, but students tend to not like it very much because it gives you hives. I mean, honestly, it gives you hives looking at it. So, good! So we got the idea of an average, we got the idea of a standard deviation. Love it. Good.
I have a question.
Oh, please, yes.
Okay, so you said that this weird shape U,
Mu and a little sigma.
little sigma, that's what the other one
That's
is?
little sigma, lowercase s in Greek. Greek letters tend to be used for population values and very important mathematical constants. Remember pi?
Yeah.
3.14. Remember phi? PHI, the golden ratio? Maybe you've heard of it before. It's okay if you haven't. It's a special mathematical constant. Root 5 plus 1 over 2. Don't worry about it. If you look at your driver's license or a picture on your desk, it's probably pretty close to that ratio. It seems to be a very appealing visual ratio. Your TI screen, if you measure the long and divide it by the short. Your cell phones are not. I love this. Cell phones are not in the golden ratio. And I kind of like that they're not. More real estate than a golden ratio. But anyway, but Greek letters tend to get reserved for very important ideas. And for whatever reason, statistics values get the Greek letters and the sample values get, I guess these are Latin letters, I guess, I don't know, English letters. Please, Linda, go ahead.
You don't have to address this now if it's.
No, go ahead, please, let's see if we can.
On the gas and diesel thing, I did it kind of the long way, and I listed every single price. So if it was 8 times, if there were.
There's nothing wrong with doing that. What you did was you bypassed that.
So my question is, in Excel, I noticed there's a standard deviation for sample and one for
Yeah.
population. And I said, well, I have the entire population, I'll try population.
As long as you did it that way, you did it right.
But it came out a different number.
Let's
from
take a
the
look.
sample one.
If you don't mind, let's take a look at break. Well, I'll throw a spreadsheet together. We'll crunch it real quick. It shouldn't, but we'll take a look. We'll take a look, promise. Cool. So my concern is we now know a lot about the average and the standard deviation of a set of data, and we're happy about that.
Yeah.
But my concern is that are there any times we shouldn't use averages?
Yeah.
Can an average ever be misleading?
Yeah.
Well, of course they can. Give me an example of when an average could be misleading. Kevin, help me.
So on one of your additional, what was that called?
Oh, the little extra resources?
Yeah,
So you're the one that's been looking at it.
I was
Good.
explaining to my roommate last night, and what I told him is like the average house price example that they used.
Yes.
And so they had almost all of them were right around like 60,000.
Uh-huh.
They had one person that ended up making 5 million. And so they said the university would be beneficial to say that the average graduate earns, $700,000 a year.
Because that's what the average is. This what the average is. Larry Bird was an example of this. It was funny to find another example of that exactly. Yes, when you have highly skewed data, averages, where do averages head in a data set? Do they head always to the center, or the median center, or will they chase they'll chase the tails, they'll chase the outliers. That's when you have to watch averages, when you have outliers. Now, I know we haven't mathematically defined an outlier yet. I know that. It's coming soon. Your textbook mentions it 3 times. Literally, I did a find on your textbook, 700 pages. The word outlier is used 3 times and never formally defined. That's a crime too. That's a crime too. So I developed a section all about outliers. We'll get to it probably end of next week. But I want to talk about, before we define that, are there other tools we can use besides just pure averaging and standard deviationing? Because you can avoid the average by going with the median, right? But the problem is, this is not based on a median, it's based on an average. So if the average is out, technically speaking, so's him, her, she, so's it. Because it's based on that skewed value. So you probably should throw them both away. Is that fair enough? So I thought long and hard, and I decided the best way to tell you about this was to talk about Max. This is my little guy on his second year